Hello friends, I welcome you in lecture number 2 on graph theory. In lecture number 1, we have introduced definition of graph and we have understood some definitions related to graph theory. In this lecture also we will continue with the basic terminology of graph. So we will see some definitions and try to understand them. The first definition is loop or sling. Loop is that edge of a graph which joins a node to itself. An edge of a graph which joins a node or vertex to itself is called a loop. For example, suppose I have this graph. Suppose this is the edge connecting these two vertices, and suppose I am having an edge which starts at this vertex and ends at the same vertex, then this edge is called a loop. So loop is that edge whose initial and terminal points are the same. So remember that an edge of a graph which joins a node to itself is called a loop. Now for loop we can consider it as directed as well as undirected edge, because direction of a loop is of no significance. Therefore, loop can be considered either as a directed or undirected edge. Next definition is parallel edges. Parallel edges means, suppose I have this graph, and suppose I have an edge connecting these two vertices, and suppose I have another edge connecting these same vertices, and suppose we consider them as undirected edges, then these two edges are called parallel edges. And if we are talking about directed edges, then they must be in the same direction. So if I have directed edges from vertex v1 to say v3, and if both are in the same direction, then they are called parallel directed edges. If I have this type of situation, one direction is from v2 to v4, another direction is from v4 to v2, then we will not consider these two as parallel edges, they will be considered as distinct. In the case of directed edges, direction matters. If both are in the same direction, then they are called parallel edges. So that is meaning of parallel edges. In some graphs, directed or undirected, we may have certain pairs of nodes joined by more than one edge. Such edges are called parallel. That means, suppose I have this pair of nodes and they are connected by this more than one edges. So all these edges are called parallel edges. And if in a graph there are some parallel edges, then that graph is called multigraph. Any graph which contains some parallel edges is called a multigraph. For example, if I am drawing this graph and suppose I have these two parallel edges between these two vertices, then this is an example of multigraph. Suppose I have two loops at the same vertex, then those two loops are also called parallel edges. So any graph which contains some parallel edges is called a multigraph. And if in a graph there is no parallel edge, then that graph is called simple graph. If there is no more than one edge between a pair of nodes, or no more than one directed edge in the case of a directed graph, then such a graph is called a simple graph. Simple graph means there are no parallel edges between any pair of nodes. This is simple graph. We can consider this as a simple graph. There are no parallel edges between any pair of nodes. If there is no more than one edge between a pair of nodes, or no more than one directed edge in the case of a directed graph, then such a graph is called a simple graph. So here I have taken these three graphs. You can see in graph A, there are parallel edges joining the nodes 1 and 2. There are two loops at this node 2, and between 2 and 3 also there are parallel edges. So this is an example of multigraph, or we can say that there are parallel edges in this graph. This is undirected graph. Here in this B we have directed graph, and for directed graph we have to consider direction as importance, because if we have two edges joining the two vertices, and if they are in the same direction, then only they are considered as parallel edges. So we can see here there are two directed edges from V1 to V2. So these two are considered as parallel edges. This edge and this edge are not parallel edges because they are going in opposite direction. They are considered as distinct. Similarly, this one and this one are also going in opposite direction, so they are not considered as parallel edges. From V2 to V3 we have one directed edge, and there is one directed edge from V3 to V2. So here also direction is different, therefore these are not parallel edges. So we have only one pair here joining V1 and V2. So there are parallel edges joining V1 and V2 only, and because there is one parallel edges, this is also an example of multigraph. This is also directed graph. All the edges are directed edges, but we can say that the edges joining the given vertices are going in different directions. Here we have an edge from 1 to 2, so that we will write as order pair 1 2, and there is another edge, but it is from 2 to 1. So these two are not considered as parallel edges. Similarly, we have edge between 2 and 3, that is 2 to 3, and edge from 3 to 2. So here order is important because we have directed edges, so these are also not parallel edges. Similarly, we have an edge from 1 to 3 and an edge from 3 to 1. So there are no parallel edges or no multiple edges in this graph. So this graph is also considered as simple graph. Simple graph means there are no parallel edges. There is another definition known as isolated node. So isolated node means the node which is not adjacent to any node. For example, if I am considering this graph, then you can see this vertex or node is not adjacent to any node. Adjacent means it is not connected to any other node by any edge. So that type of node is called isolated node. In a graph, a node which is not adjacent to any other node is called an isolated node. We have defined the definition of adjacent node in earlier lecture. We know that if two nodes are connected by an edge, then they are called adjacent nodes. So isolated node is that node which is not connected by an edge to remaining nodes of the graph. So isolated node is not adjacent to any other node, and that is the meaning of isolated node. Next definition is null graph. Null graph means graph containing only isolated nodes is called a null graph. That means there are no edges in the graph. Suppose I have this graph. Suppose I have three vertices V1, V2, V3, and they are not connected to any other nodes. Then all the nodes becomes isolated, and this graph becomes null graph. So null graph is that graph in which there are no edges, or the set of edges of a graph is an empty set, or phi. So if there are no edges in a graph, then graph is called null graph. In other words, a graph containing only isolated nodes is called a null graph. So we have written here the set of edges in a null graph is empty. So this is some basic terminology which I wanted to discuss in this lecture. We have understood the meaning of parallel edges or multiple edges, and using parallel edges we have defined multigraph and simple graph. Simple graph means a graph in which there are no parallel edges. Multigraph means a graph in which we have at least one pair of parallel edges. We also defined isolated node. A node which is not connected to any node by any edge is called isolated node. And null graph is that graph which contains only isolated nodes. That means the graph in which the set of edges is empty set. So remember all these definitions. We are going to use them repeatedly in upcoming lectures. And we have understood loop also. Loop is the edge which starts at the vertex and ends at the same vertex. So loop is that edge whose initial and terminal node is same. So we will continue with this in upcoming lectures. Thanks for watching.